If you own a DSLR or mirrorless camera along with a lens, it's possible that you could turn that into a fully automated electronic smart telescope. Basically, you'd be controlling everything with a smartphone, telling the telescope which target, like galaxy, nebula, star cluster, to point to, and the camera will move there, point there automatically, and then start taking exposures, accumulating light on the targets, and then showing you the results on the smartphone so you can see your target, your galaxy, better and better as time goes. It's a really fun project. It can get great results even from a very light polluted area in the city, like here in Tokyo. Today we're going to learn how to build that. I've recently done a video about how I built a full-fledged smart telescope based on a small telescope and astrophotography dedicated camera, but I got lots of feedback about can I do this with a DSLR or a mirrorless camera, and the answer is yes, yes you can, and we're going to do this today. I will reuse some of the parts from my previous video, so if you see this setup change slightly throughout the video, don't be panicked. All of the instructions are correct and you'll be able to skip or go to the proper parts of the video as you desire with chapters at the bottom of your screen. As a quick overview of what I have here, I'm using my Pentax K1 DSLR along with a 135mm f2 lens from Samyang or Canon in the United States, and this is on a small mount called the AZ-GTI, and this small mount is what is going to be pointing to the correct stars, correct targets, and then track those targets, because as the Earth is rotating, you'll need to track those stars properly, and this will do that task. We're also going to be controlling everything with a little computer here, which is a Raspberry Pi based computer, and we're going to have set everything up on a tripod, and we will also use a mobile battery with quick charge available, so we're sure it has enough power to give to the Raspberry Pi to actually power the Raspberry Pi via USB-C. And there is one more thing that is needed, which is kind of a dovetail plate for telescopes, and this will make attaching the camera to the mount very straightforward. There will be links in the description to all of the material that you need to accomplish this build. The first step of this setup are determining whether your camera and lens will work well as a smart telescope. Let's start with the lens. Ideally you want a lens that's over 100mm in focal length, and you want a lens that is as fast as possible. This is why I've been choosing the Samyang 135mm f2 lens, which is really fast and has a very good reputation for astrophotography. It's typically known as the Canon 135mm f2 lens in the United States. Some other good lenses, by the way, would be, for instance, the Canon 200mm f2.8 lens, which has a great reputation in astrophotography. And on the Nikon side, you also have, I believe, the 180mm f2.8 lens, which should give great results with this. So that's really for the lens part of the setup. For the camera part of the setup, we need to figure out if your camera is supported by the software that's going to be in our little control center here. The software is called Stellarmate, and there's another thing to understand with the camera is that older cameras with fewer megapixels will actually work better than newer cameras. The reason being that there will be a lot of image processing done within your little control center here, and the fewer megapixels it has to deal with, the faster it's going to be able to process the pictures and show you the light accumulation on your targets. My particular camera here, the Pentax K1, has, I believe, something like 36 megapixels, so it's actually a bit too much for that particular application. Still, we're going to make it work. The safest way to check whether your particular camera is supported is to look on the Stellarmate support page. I'll be putting the link in the description down below, and you can see my computer screen right now. And we have a list of Canon DSLRs, including something like the 1100D, which was actually my first astro camera, and would work great in this solution. You can also look on the Nikon tab for the Nikon side of things. You'll also notice that my particular camera here is not in that list, but it does actually work. So it's not an exhaustive list, but if you see it in this list, you know that it should likely work well for this project. You can also double check a second link, which I'll also put in the description, which is the supported camera link. And I believe that if image capture is supported for your particular camera, it is going to work for our application. I am not 100% sure though, because I do not have other cameras to test than what I have here. So it's a bit of an at your own risk kind of thing. If you're not sure whether your camera is supported, do know that a Raspberry Pi is actually a very versatile little computer. It can be used as a media center for your TV, for instance, and it can be reused for a variety of hobby projects. So you could always buy a Raspberry Pi, test it with your camera, and if it doesn't work, repurpose it for something else. The OS itself, the Stellarmate OS that we're going to use for controlling everything, is still $50, so you wouldn't have thrown $50 out of the window if you end up with something that doesn't work with your camera. So at your own risk, please be cognizant of that before you start buying stuff for this project. After a lot more testing than when I first recorded this video, I want to give a bit more advice on camera and lens. On the lens side of things, you can see that I'm using a different lens here than I have in most of the video. This is because with my full frame sensor, I noticed that a 135mm lens really didn't have enough zoom and had too much of a wide field, and I was forced to also stop it down to f4 to reduce the vignetting, which can really mess up with light accumulation algorithms. And so instead I'm using this lens, which is a 200mm f4 lens, which I can use actually at f4 pretty decently, and that lens is very old and I bought it used for like $30. So I really recommend to, as much as possible, avoid full frame cameras for this application. APS-C will work much better. And also, like for lens focal lengths for full frame, you really want something like 200mm, and you want a lens where you will have as low vignetting as possible. So if it's a fast lens, you have room to close it down a bit. And on APS-C, I think like 135mm might kind of work, and 150 and above is a bit probably better. I will also add on the cameras that I tested with a completely unsupported camera, which is the Canon EOS M50 Mark II. And I cannot show you because this is the camera that I use for filming, and I don't have any other camera lens combo that works well for filming. But I tested with that, and even though it was unsupported, I was able to configure it. I had to input the number of pixels of the sensor, the size of the sensor, and the pixel pitch. So it was not super easy, but I was able to do all of that from the app. And also what was very cool when I was using my Canon EOS M50 Mark II with a 200mm lens on it, is that I could actually control from the application the focus motor of my lens, and I could even autofocus on the stars with a bit of configuration. This video is not going to go into the details of how to use the focus of your lenses, but if you end up opening up the app and seeing more icons than I have, in particular a magnifying glass icon, this is where you can control the focus for your lens. Anyway, that's what I wanted to add on the cameras. And yes, there is a lot of variability between lenses, between cameras, so be prepared if you see you have issues to close down your lens a little bit to get the ISO higher while you're doing this kind of stuff. So unlike the last video where I had like set equipment, so I could make sure that everything worked well all the time, here it really depends on your equipment, and there will be some improvisation and tinkering that you will have to do potentially. Anyway, let's go back to the tutorial. The first step of assembling this setup would be to put the mount that's going to track the stars onto the tripod. Now, depending on what you bought, you might have bought the mount head only, and then you need a photo tripod like this one with a 3/8 of an inch screw at the top, and you just screw it in. Or you might have gotten the version of the mount with a tripod, in which case you just use them together as necessary. So now you see I've just like screwed the mount in. I can also tighten. This is the clutch for the horizontal axis basically, and by tightening it, I make sure that the mount doesn't move on its own. So I'm properly tightening on the screw of the tripod. If I remove the crutch and I do this, the mount itself is turning. There's a circle there that turns, and it doesn't screw into the tripod anymore or unscrew. While we're at it, you are able to power this mount using a 12-volt DC input here, but you can also use batteries, 8 AA 1.5 volt batteries in here, and that way the mount will run off of its own power. So here we are, and the mount itself with that is, in terms of hardware, ready. The next step would be to attach your camera to the dovetail attachment that is on your AZ-GTI mount. To do so, I am going to connect it via a dovetail that has a 1/4 of an inch screw adapter within it. You have other attachment options to the camera, for instance something that keeps your camera horizontal like that. It doesn't really matter for our application. You can choose whatever works the best for you. I'll have a few suggestions down in the links below. So since I have this 1/4 inch screw, I can simply directly screw it into the camera. While I do this, I want to make sure that the focus ring and the lens can still be operated. You can see I have actually a very, very small gap in between the lens focus ring and the dovetail plate in my case here. My particular screw on that dovetail plate is actually supports an Allen wrench, so I'm going to use an Allen wrench to tighten this up. Now this step is actually fairly important now that I've tightened it. You want to make sure that the dovetail plate here is as parallel as possible as the optical axis. This is because there is a phenomenon that is called field rotation that we have when we use a little mount like this. And having the dovetail plate that is parallel to the optical axis makes things easier in terms of that field rotation. You can still eyeball it like I'm doing here, and it looks not bad at all, and make sure that it is very tight, either with a screwdriver, a coin, or an Allen wrench, depending on the screw that you have in there, so that the optical axis will not shift while you are using it on the telescope. To avoid shifting, having a better kind of like horizontal connection to the telescope is actually better, but because I'm able to tighten things quite well with the Allen wrench, I'm going in this direction. Now that I have the dovetail plate properly attached to my camera, I can simply slot it within the mount here and tighten the screw here at the top. And that's pretty much it. Here we are with the mount holding the camera in place, and I can also make sure that I have a clutch here. I can loosen the clutch and make sure that it moves vertically as well. And now we are ready with the mechanical part of the assembly. We're now going to look at the software part. For our next part, we'll need a micro SD card along with a micro SD card reader. The micro SD card actually came for me with my Raspberry Pi kit, and I'll just now use my computer to actually prepare the SD card to work with the Raspberry Pi module. The first thing that we need to do on the computer is go to stellarmate.com. You'll have the links in the description down below, but you will need to create an account and you will want to buy the product called Stellarmate OS. It costs, I believe, around $50 US. While you are purchasing that OS, you will be asked to create an account. So the next step will be to sign in to be able to download the Stellarmate OS that we are going to use to control everything here. Once it is downloaded, we are going to basically burn that image to the micro SD card. To do so, we are going to go to etcher.io. Again, we'll have the links in the description. Then we are going to download for Windows, click the download button and install this. The install process for Etcher is very simple. You double click the downloaded executed file, you agree, and that's pretty much all there is to it. Once the install is done, it should open up with the Etcher window. And here we have it. I will choose Flash from File, And we are going to select the Stellarmate OS image file that we just downloaded from the Stellarmate website. So here it is from my downloads folder. I will just double click that to open it, and now we need to select our target. To select our target, your micro SD card must be plugged into your PC and recognized by your PC. You will want to be very careful about which drive you select, just to be sure, because you do not want to flash this on a drive where you would lose all of your data if you chose the wrong drive. So here I am choosing definitely my micro SD card. And the next step is just to click on the flash button, and it is going to ask you whether you want to make changes to the device. You say yes, and it is going to flash the image. So the only thing that you need to do is to wait until it is done. While we are waiting, we may want to install two applications for smartphone that we will need. Those are available for both Android and iOS. We want one application called Stellarmate, which is going to be used to control our little Raspberry Pi computer from our smartphone, and another application is called Synscan Pro. And Synscan Pro is used to actually control this little mount here, but we're actually not going to use it to control the mount. We're going to use it to set the mount to connect to the Wi-Fi hotspot that is generated by the Raspberry Pi. It sure has now finished burning the image to my micro SD card, so I can remove it, and here it is, and we're going to insert it into my little Raspberry Pi device here. Now, this device, I built it up from a Raspberry Pi kit, so you likely bought one as well. And depending on your kit, the instructions to assemble it could be different. I made sure to choose a plastic case to make sure that the Wi-Fi network generated by our Stellarmate OS has a long range. And the instructions within my kit was super clear on how to assemble everything. It was sticking a few heat sinks on some of the chips. It was screwing in a little fan and then plugging that fan into two little pins, and there was a very nice pin diagram to know which pins to use. Very easy to do. I'm not showing it on camera here because the steps will be different depending on the kit that you have chosen for your Raspberry Pi. The important thing is that we have the USB ports here, and we have a USB-C port on this side as well, and this is what is going to power the Raspberry Pi. And on the bottom side of things, I have the micro SD card reader. So I am going to insert my micro SD card into the micro SD card reader, and the orientation is somewhat smart. It is with the little SD card bump facing towards me when I want to remove the card using my fingernails. Now that we're done with installing Stellarmate OS on the little Raspberry Pi, you can see that I have attached the Raspberry Pi on my tripod leg using a simple Velcro strap, and I'm going to do the same with my quick charging compatible battery, which will be providing power to the Raspberry Pi for the first boot. And the Raspberry Pi, together with the Stellarmate OS that we just installed, will be the brains of the operation. This is thanks to this that we'll be able to control everything from our smartphone and see the results of our smart telescope, our DSLR-based smart telescope, on the smartphone. So I'll first attach my battery to another tripod leg. You probably have better methods for doing that, so feel free to improvise on that point. Okay, and now that we have this here, what I'm going to do is basically the first boot of the Stellarmate. And there's no on-off switch on the Stellarmate. There is a simple USB-C port here next to my finger here, and we're going to be able to turn it on by plugging the USB-C cable directly from the battery. And now it is booting up. The first startup will take a few minutes because it's initializing a lot of things. So let's just wait like 5 minutes, go and grab a coffee or something, come back in 5 minutes, and then we'll be ready to go for the next steps. While the Stellarmate is booting up, I am going to use, for me, it's a micro USB cable, and I will just be plugging in into one of the USB ports of Stellarmate and then plugging into my camera. Now this step, it really depends on your camera model. Typically, if it's a Canon camera, I think you'd have very similar steps. I have not used Nikon cameras in the past, so I cannot say. For my Pentax, it's just micro USB to the camera. At the same time, on the mode dial of your camera, you want to make sure that you have the bulb mode selected, and within the bulb mode you need to make sure there's no specific time period that's been set up. In Canon mounts, bulb mode is sufficient. In my Pentax DSLR, I need to actually tell it that it's a real bulb mode. On Nikon cameras, I do not know how it works. On some cameras, there is no bulb mode in the selector, and you need to put it in the manual position, and then within the menus set it in bulb. So it really depends on your camera. There are some troubleshooting guides on the Stellarmate webpage, but again, this is a place where depending on your model of camera, you'll have to fight it on your own until you make it work. Now that Stellarmate, the Raspberry Pi, has booted, we've waited a few minutes, so we're going to assume it's all done. We're going to try to connect to it from Wi-Fi. So I'll be using my phone for this. Okay, the first thing, we're going to check whether the Wi-Fi hotspot that is broadcast by Stellarmate OS is available. So I'm going to go into the Wi-Fi settings of my phone, and we are going to see if there's a network called Stellarmate, and here we have it. I selected it, and now I can input the password. The password is, as you should see on the screen, Stellarmate, and we're going to click on connect. Once it's connected, you may be getting a message like Stellarmate has limited connectivity. You want to click on that message, don't ask again for this network, and yes, you want to stay connected anyway. That's important, otherwise your smartphone could disconnect you from the Wi-Fi hotspot and you would no longer be able to control your smart telescope until you reconnect the Wi-Fi. So now we are connected to the Wi-Fi hotspot that is broadcast by the Stellarmate OS. And now that we are connected to the Wi-Fi network, we can open the Stellarmate application. On the first opening, you will get a sign-in option. So you will want to make sure that you have internet connectivity on your smartphone for this sign-in option. It might require you to disconnect from the Stellarmate Wi-Fi, connect to your home Wi-Fi and then back, but make sure that you have internet connectivity when you're doing so. And to be clear, these are the identifiers that you have created when you first purchased Stellarmate OS. And now I have signed in, so I am on the welcome screen of Stellarmate OS. So before proceeding, make sure that you are connected to the Stellarmate Wi-Fi hotspot. And the first step that we're going to do is we're going to tap the rescan button on the top right, and you can see that immediately on the left this created a profile, Stellarmate. It's a connection profile to our little brain of our smart telescope. So I'm going to tap on that profile and it is going to automatically connect to the device. Now that I am connected to the device, there are some settings that I need to do. Now, in my previous video, I showed a way of how to upgrade Stellarmate OS to the latest version, and it was using remote desktop into Stellarmate OS. This is no longer necessary because the latest images of Stellarmate that you have bought contain some of the improvements that were necessary. Still, I will show you how to upgrade Stellarmate OS from the app, and if you're not interested, you can always skip to the next section using the chapters at the bottom of the video. So the first step would be to go to Device, and you can see we have the hotspot mod on the top right with a gear icon next to a green antenna icon. I'm going to click on that gear icon, and this will let me join my home network as necessary. So I can just select my home network from the list of available networks and then input my password. Once I click the connect button, I get this warning message that asks me whether I am sure I want Stellarmate to connect to my home Wi-Fi. Because that means that Stellarmate will stop broadcasting its own Wi-Fi hotspot. So I am sure, and then I will be switching my phone to my home Wi-Fi. And here we are. I am now connected to my home Wi-Fi. I can go to the Setup tab on the left, and we're going to wait until the Stellarmate device, which is on our home Wi-Fi now as well, is detected. And now that it has been auto-detected, you can see Stellarmate again appearing as a connection profile on the left-hand side with a different IP address than before. I'm going to tap on it. Now it is available again. I can go to Device, and because I am now connected to a network that has internet access, I can scroll down and you can see that we have now a software section at the bottom of the page, and I can check whether there is an update available by clicking the double arrow, circular arrows button, and it will let me know if there is a new version that I can upgrade to. If there is, there will be a little button to upgrade the Stellarmate OS to the latest versions. Now I've noticed that sometimes the upgrades don't go smoothly, in which case you may need to reflash Stellarmate from scratch. So it's always better to kind of like have a secondary SD card or something like that, just in case something goes wrong. And you can see that in my particular case, it told me that it is already up to date, so there is nothing for me to do. I am going then to go back to the top right kind of gear icon next to the antenna icon, and I'll be able to select the Forget Wi-Fi button. This will make Stellarmate disconnect from my home Wi-Fi and then broadcast its own hotspot Wi-Fi again. So I click there, I get a warning, and yes, I want to continue. Now I want to connect to the Stellarmate hotspot, which should appear momentarily, and here it is. I connect to it just like before. I did have to wait like 30 to 60 seconds before it appeared again, so please be patient. And I'll go back to the application, and now I can say, okay, I am connected to the Stellarmate network, and the application will try to connect back to it automatically. And if it's taking too much time, you can always go back to the Setup tab and click on Rescan, and you'll have the connection profile appear on the left-hand side. Now I'm connected again to Stellarmate, and this is how you upgrade Stellarmate if there's a new version that's available. I recommend, if you have Facebook, to join the Facebook group for Stellarmate, because then it will tell you when there are new versions available. And new versions can provide enhanced light accumulation technology, so it's always good to have that in mind. Now we need to do one more thing on our Stellarmate OS before we can go on to the next step, which will be to connect the mount here that has Wi-Fi connectivity to the Stellarmate OS. So the mount will connect to the hotspot of the Raspberry Pi device, but for that we need to make sure that the Wi-Fi band for that device is set not to 5G but to 2.4G. So in the device tab you have the Wi-Fi band towards the top, currently set to 5 GHz, and I am going to click the gear icon next to it and say that I want to switch it to 2.4 GHz. If we don't do that, the mount and the brain of our setup will not be able to communicate together. So I'm going to click connect. It will ask us whether we are sure to change the band, and yes, we are sure. And actually for me in Japan, it's a regulatory requirement. I am not allowed to use 5 GHz Wi-Fi outside a house. So we say yes, and this will again recreate a Stellarmate hotspot with the new 2.4G network. And just in case, I like to double check in an app called Wi-Fi Analyzer. You can see here I have selected the 2.4 GHz band, and we can see the Stellarmate network is definitely there. So we are currently on the correct band for Stellarmate to work together with the rest of the smart telescope. The next step for us will be to configure the Synscan Pro App for this mount to connect to the Stellarmate hotspot. So let's get that going. The first thing I am going to do to set up this little mount to connect to our Stellarmate control center effectively is I am going to turn it on. What this will do is that the mount will broadcast a Wi-Fi hotspot that we can connect to, just like we did for the Stellarmate hotspot. And as you can see here, we have that Synscan hotspot that's available. This is what I will be connecting to. Now we will launch the Synscan Pro app that we downloaded earlier. I'm going to launch it. I am indeed connected to the Synscan network. You want to make sure that the app has permission to use your location, otherwise you'll have to set the location manually. I'm going to click on the connect button, and it is going to immediately find and connect this little mount, which, you know, from the app directly I can actually control to make it turn on or whatever. But we're not doing that right now. For now, I'm going to go inside the settings, and I'm going to select Wi-Fi setting here. In there, we're going to enable the checkbox for modify station. We're going to enable station mode, and we're going to put SSID as Stellarmate. Here it is. The password will be Stellarmate, just like when we connected from the computer or from the phone. And we do not want to use DHCP. I'm going to put a fixed IP of 10.250.250.20. And this is what we are going to use as settings. So now I'm going to click on the apply at the top right of that screen. It's going to take a bit of time to apply the settings. What it's doing, it's actually attempting to connect this little mount to the Stellarmate Wi-Fi hotspot. If it succeeds, we'll see when we refresh. If it didn't succeed, something went wrong. Either you forgot to set the Stellarmate network to 2.4G, or some of the settings you have, like the SSID or the password, were incorrect. Let's click on refresh here to see our status, and if it was successful, we will see the SSID stay to Stellarmate. If the SSID is blank, it means that it failed and you need to try again. And with that, I do not need to use my Synscan app anymore. From my phone, I am now going to connect back to the Stellarmate network, because now we have the Stellarmate here is connected to the mount, and my phone will all need to be on the same network. So I'm connecting back to that. Okay, now that we have connected the mount to Stellarmate, Stellarmate and the mount can talk together, which is great. And we are now able to configure the brain of the computer to connect to the mount and to connect to the camera and to be able to control everything at once. So I am first going to turn my camera on, and in this particular camera it will actually detect that the USB cable to the camera is connected and put it in PC control mode. How this works on other cameras is something that I do not know, so it's something that you may have to figure out on your own. So I am on the Stellarmate app page. I'm connected to the Stellarmate Wi-Fi, and I'm connected to my equipment profile. And I'm connected to my Stellarmate. The mount also is connected to Stellarmate. The camera is connected to Stellarmate, and it is on. So we are ready to proceed. The first thing we need to do is create an equipment profile. So I'm going to tap on the plus icon right next to equipment profiles and simulators. And this is what is going to appear. In the mount option itself, I will select in here the AZ-GTI Alt-Az. And there it is. So I have selected for the mount AZ-GTI Alt-Az, and for the CCD, I will need to choose the correct driver for my camera. So if you have a Canon camera, you'll look for Canon DSLR. If you have a Nikon camera, you'll look for Nikon DSLR. Sony, Fuji, you have Sony DSLR, Fuji DSLR. And for me, I have a Pentax DSLR, but I'm not going to use Pentax DSLR Legacy. I am going to use Pentax DSLR Native. And here it is. And this is pretty much all that I need to select for this profile. I need to put in a name at the bottom. So I am going to name it Demo. And click on the Save button. And here we have the demo profile is available. The next step is I need to specify my primary scope. So I am going to, again, next to primary scope, click on the plus button, and we're going to put vendor like Canon. It's basically the make of my lens. And model like 135mm f2. And we're going to put the aperture, put whatever random number in there, doesn't really matter, 50. And the focal length is what is important. You want to put the correct focal length. It's very important for Stellarmate to know your focal length, because thanks to the focal length, it will know your field of view, and so it will be able to detect where it is pointed by taking a picture of the stars and analyzing which stars it is pointed at. Here we are, and I'm going to click Save. And you can see that now I have the equipment profile demo selected and the primary scope set as Canon 135mm f2 lens. Before we go further, before we press the start button, let's go quickly to settings and make sure that on the right hand side under auto sync you have location set to auto on. That way the location from your smartphone will be shared with Stellarmate, and it will know how to control everything. It will know where on Earth you are, and it will thus know where to point the telescope. And we are now ready to click on that start button. So I'm going to click on that start button, and it is going to launch the control center and connect to all of the devices at once. You will now probably get a pop-up like the one you see on the screen right now, which is asking you how to connect to the mount. Make sure you select network and then put the IP address that we set up, which is 10.250.250.20, with the port number between being 11880, and you select UDP. Then you can click connect on connect all. If you do not get that dialog and you've never connected to the AZ-GTI before, you can obtain it by clicking on the port selector button here and then setting the right parameters. We're first going to check that we connected to the mount correctly. I'm going to press on the eCost tab, the second from the left, and at the top right of the screen you see two icons. There is a T for telescope and then there's a camera icon to control the telescope and the camera respectively. I'm going to click on the T icon and you can see we now get a little bit more information on the screen. I can always click again to remove that information. So enable and disable things. The icons on the bottom are the mount speed, how fast it will move between targets. We also have P for parking. It means the mount is parked at its home position. We're going to use that later. The icon on the right of P is saying whether the mount is tracking the stars. So if it's on target, but this icon is in red, it means it's not tracking and you're not going to get good results. In theory, it should do everything automatically. And at the very right, there is like a one-way do not enter stop kind of button. And this is to make the mount stop moving. If at any point you see your lens is going to hit the tripod, for instance, that's the button you want to press. So for now, I want to make sure that the P icon is in red, meaning the mount is not parked. If it's green, just click the green P to make it red. And I'm going to use the arrows on the left and right of the screen, and I'm going to click on the up arrow. And this will tell me whether the lens and the camera are properly set in the telescope. Let's press on the up button. And you can see the telescope is now slowing downwards. That means that I haven't set it up correctly. So what I will do is I will simply remove the telescope and set it up in the other direction in exactly the same way as before. And here we are. Now we know that the camera is properly set. I'm gonna loosen the clutches on the mount so I'm able to move things a bit freely, and I'm going to show you what the home position of your telescope will be when you set it up outside. Basically, you want to make sure that the camera and lens are horizontal, more or less. It can be completely, approximate. And then you're going to tighten the clutch for the altitude axis, for this axis here. So you can see the clutch here is tightened. I can then move the mount laterally like that using what is called the azimuth axis and point it very roughly towards the north. Let's say that north is in this direction, and that's it. Then I can tighten this up. And this is what we do to set up the mount initially. So now we're completely ready for the mount. Let's now have a look at the camera itself on the smartphone. So I'm going to click the top right camera icon, and immediately you can see on the right some icons appear. The top right icon, which is like a white camera icon with kind of like a Wi-Fi signal, will take one exposure. And the bottom icon is a gear icon that gives you settings when you press it of the type of exposure that you want to take, as well as the ISO that you want to take it at. And for most cameras, an ISO of 1600 works pretty well, although you can really push it because we're going to do live astronomy, so it's fine to push the ISO to something a bit higher. So maybe I'll put it to 6400 so I can see my objects on the screen more quickly, or even like 12,800. It's not going to get the best pictures, but we are not trying to do astrophotography, we are trying to do astronomy that is assisted via our smart telescope. Also, another parameter is exposure here, which is the length of your exposure in seconds. Right now I can keep it at 1, but later on I'll probably want to put my exposure length to like 20 or 30 seconds, because for the light accumulation to happen, it needs a bit of time to do all the computation, the image processing in the background automatically. We're going to test whether the camera works correctly, so I'm going to tap that white camera icon with the Wi-Fi antenna there, and it's going to be taking an exposure. and there it took an exposure. And because this is a 36 megapixel camera, it's going to take a bit of time for the exposure to appear on my screen. And this is why cameras with much lower pixel counts are actually much better for this particular process. Which means that really like an old used Canon 1100D is perfect for this application, much better than the camera that I have here. And you can see the camera actually showed me, I have now the picture taken from the camera on my smartphone. So it means that things are working correctly, which is great. We can proceed further. You can always remove that settings screen on the bottom by clicking on the gear icon again to make it disappear. And now I'm going to talk a bit about the icons on the top left. First, if you had issues with your camera not responding, you may want on the top left row of icon, there's a kind of trapezium with an aura or ring around it, which is this one. And if you tap it, you'll see all of the equipment that is connected to your Stellarmate. You want to click on your camera here, tab, so for me it's Pentax K1, and want to make sure that under connection it's set to connect. If it was set to disconnect, just click the connect button to actually connect the camera. You also want to make sure that the camera is on, there's enough battery, it's in PC connection mode, it is in bulb mode, etc. So again, that can depend on your camera, so it's a bit you're on your own and have fun making things work. For my Pentax, I really had no problems. Now that we've seen this option, I'm going to remove or hide this. I make sure that my camera settings are also hidden. And on the top left, I'm going to click on the target kind of icon. Here it is. And this icon is the control screen to show you how the telescope is centering the target that you've told it to go to. So what will happen when you tell the telescope to go and look at the Andromeda galaxy, for instance, it will slew to the vicinity, it will point to the vicinity of Andromeda, it will take a photo, it will analyze the stars in the pictures and determine how far away it is from Andromeda. Once it has done that, it will correct itself and actually point towards Andromeda. It really is a smart telescope. And the problem is with the default profile, it really tries to do this far too precisely. So we're going to create a new profile to do this much less precisely because we're doing astronomy. We're not trying to take actual astrophotographs. So I'm going to click the plus icon next to the preset with default there. And this particular page will appear here. Now there are some things that I will change. I will change the preset name to DSLR. And I am also going to change the exposure by clicking on the pencil icon next to exposure to something like 5 seconds. I am also going to change the ISO to 1200, around 12,800, sorry. And I will change the accuracy to maybe for my particular camera I'll put 400 arc seconds. That should be more than enough to center targets. And try with that at first, see if it works. And then on the top right, I'm going to click on the floppy disk icon to save this profile. And here it is, we are on this profile. At any point, if you feel that the smart telescope is having trouble centering a target, you can always go to that tab to see what's happening. And you can also stop the centering and redo it manually by clicking on the capture and solve button here. When we say solving or plate solving, we mean analyzing the stars that the telescope is pointed to or the camera is pointed to determine where in the sky it is pointing to and then correcting that. So that's what we mean by solving. And those are basically the settings that we need for the camera. Now we're going to look at one more setting within the camera tab using the top right button. It is the live icon that we have on the right hand side of the screen here. And the live icon lets the camera take multiple pictures one after another and then it stacks them on top of one another. And that is the light accumulation for that picture. And this is what we're going to use in the end. The live, and there is a play button on the left hand side of that live setup screen. And once you click that play button, it will take exposures one after another and stack them. Now with a camera with a lot of megapixels like that, I want to make sure first that in the settings I've set the exposure time to maybe 30 seconds to make sure that the processor will have time to stack the pictures between one and the other. The next tab that I want to draw your attention to is the Targets tab here. So it's the third from the left. And this is where you can see the targets that we will want to point at and actually have a look at, right? So we have the Andromeda Galaxy, we have tons of galaxies here that we could look at. On the top right, you have different sections that are available, like nebulae, that kind of stuff. So you can really search for stuff that is interesting to you. And next to each of the images, you have like a white line that goes up and down, like a pyramid or a mountain, and a yellow line that crosses it. The yellow line represents the current time, and the white line represents the elevation above the horizon of that particular target. So we can see that around 11 p.m. The Andromeda Galaxy will be at around 80 degrees above the horizon. So that tells us, where the object in the sky is to some extent. When I want to salute that object, I will click on the Go To and Solve button that is on the right of that object. And if I click on this now, we should see it try to actually go towards the Andromeda Galaxy. How cool is that? I absolutely love to look at this smart telescope just like going to a target. And now it's actually going to try to take a picture to figure out where it is in the sky. So I'm going to go to the ECOS tab, the target on the top left, and click on the stop button because I don't want it to do that. There's no stars. Yeah, that is how it's going to work overall. Now another thing that I want to tell you is how to turn off and on everything. What you want to make sure of is that you turn off the mount before you turn off the Raspberry Pi control center. And the first thing that I would do before turning it off is go to the telescope tab here and click on the red P. This basically parks the mount to its home position. Once it's done, the P becomes green, so we are now parked. And I now want to go to the Setup tab, and I will click the Stop button next to the equipment profiles. This will sever all connections between Stellarmate and the smart telescope. Once this is done, I can turn off the mount. So I'll just use the switch on the mount to turn it off. And then I can go to the Device tab, click on the bottom left button, which is kind of like turn off, and we are going to shut down Stellarmate. Shutting down takes a couple of minutes, so we wait a couple of minutes and then we can unplug the cable to completely turn it off. And turning it on is exactly the same process, but in reverse. We would plug back the Raspberry Pi into the mobile battery. We'll wait a couple of minutes until the Stellarmate Wi-Fi network is available on your phone. Once that's done, you can turn on the mount. And once the mount is turned on after 10-50 seconds, in the Setup tab, you can click the Start button under Equipment Profile, and you're good to go. We are now outside and we need to do an important step to prepare for using our smart telescope, which is focusing the lens to infinity. My particular lens comes with an infinity slider, so I'll start by setting up at infinity directly, and then I will use the live view of the camera to properly focus. So I will just turn on the live view. I don't know how easy it is to see on the camera, probably very difficult, but I can just, for me, I'll zoom into a faraway forest or trees here and just manually focus until I see them in focus. We need to absolutely use far away objects. And if your lens has autofocus, just set your lens to autofocus. Use autofocus to get the far away object in focus, and then set the lens back to manual focus and you're done. So it's a very simple and easy first process, and then you don't touch the lens anymore until we are under the stars. We are now ready to set up our newly created smart telescope for the night, and it is very easy to set up. So I just plopped the tripod down. I'm going to use the clutch here and make sure that it's roughly horizontal. The lens is roughly horizontal. And I am going to use the clutch here to make sure that I'm pointed roughly to the north. To figure out whether I'm pointed roughly to the north, I can simply use a smartphone app. We don't need to be very precise. This will be good enough. And I will tighten the clutch. Now both clutches are tightened. I want to make sure that everything is connected. And of course I want to make sure that the battery of the camera is full, all this kind of stuff. And then I'm ready. There's nothing else to do except wait for the night sky to be available. And I'll see you once we are under the night sky to show you exactly how this works under the stars. Okay, we're at nighttime now, and the telescope, it's actually a DSLR, but we turned it into a telescope together, is ready to image. As you may be able to see, I'm not using the lens that I've been using all the time. I'm using a 200mm f4 lens, which you should have seen a little bit in the first part of this video. The reason is that that particular lens for a full frame sensor will give me a better, narrower field of view, so more zoom into my targets, and it has less vignetting, which makes the live stacking, the light accumulation, work better. Now, before I turn on the mount and the Stellarmate, what I'm going to do is actually first loosen the clutch here, and then randomly point the camera towards the stars. And once I've done that, what I can do is use the live view of my DSLR to focus on the stars. So you may be able to see the stars on the live view, and the goal is to make them as pinpoint as possible. You can see they get larger here, which is not what I want. I want them as pinpoint as possible. And you may want to, if your camera supports it, to use the zoom button while you're doing your focusing, and very slowly move the focus ring until you get stars that are nice and pinpoint in focus, like in this example. This is how it would be working. And with that, I am ready to put back our telescope or camera into its home position. Okay, and I have turned off the lights. I've put the lens and camera back to the horizontal position, pointing roughly north, and that's pretty much all I need to do. So my next steps will be connecting, as always, to Stellarmate. So I've turned on Stellarmate. I waited until the Stellarmate Wi-Fi was available. Then I turned on the mount, and the camera is on as well. Okay, and I'm on my phone. Stellarmate has been launched. Everything is ready, and I have the setting for my Pentax 200mm lens, along with my Pentax profile for this particular Pentax camera. I am going to start these profiles by clicking on the start button. And here we are. Now I can go into my targets. So for my targets, I can see there's the Orion constellation that's right there. So we can go towards the Orion Nebulae. So you can see I clicked on gaseous nebulae here, and we can see the Great Orion Nebulae is available. So I am going to select it and press Go To and Solve. And you can see that immediately the mount here starts moving, which is super cool. So it's going to move and point to the vicinity of the Orion Nebula that's right there. It's going to take a picture, analyze the stars on that picture to determine exactly where it's pointing, and then it will refine to go and find the Orion Great Nebula on its own. You can see it's done the original slew. Now it's going to take an exposure and automatically solve the exposure to see where it is pointed at in the sky. Now I am in the ECOS tab under the centering option, so the little target icon top left, and it took the exposure right now, and I'm following up what exactly it is doing to find if it is working and if it can center the target. So with my camera, it's a high megapixel camera, relatively speaking, so it's going to take a bit of time, and that's why an older camera with fewer megapixels with an APS-C sensor is better for this. Oh, you can see it adjusted itself right now, and it's going to take another exposure to find out if it's now on target or not. This is all automated, which is super cool. There, it took another exposure, and you can see that the alignment is complete. It has successfully centered the target, so we've let our DSLR just point itself to the Great Orion Nebula without having to do anything, which I find absolutely super cool. Now here we are in Tokyo, so there's a lot of light pollution, so really looking at the worst case scenario. However, I have one trick up my sleeve. You can even say that I'm cheating. This particular camera is what we call astro modded. DSLRs, they have a filter that filters out the red band passes of light, like infrared, but nebulae will emit a lot of that light. And my camera has been modified to be able to receive that light. So I have a slight advantage, but then I'm in a super light polluted area, so yeah, I deserve to be able to cheat. Anyway, let me turn off the auto centering screen. We can go to the camera icon here, and I am going to select a 10-second exposure at ISO 12,800 and click on the camera icon here to take that exposure, and let's see what we see. The result has appeared on the screen, so this is a single preview, and you can see in the middle the Great Orion Nebula is already visible with just a single exposure. This is so super cool. And this is from Tokyo. I love this. This DSLR is now a smart telescope. How cool and awesome is that? Okay, let me go to the live button here, and now what we're going to do is that I am going to start a live stack. Now the live stack, there are different parameters that you can adjust. The contrast, which is self-explanatory, saturation to see more or less color in the image, and then the background, and the background is how much you're darkening the background. So you can play with those at any time you want. There is the play button on the left hand side of the live stack pane that you can use to start the live stack, and then there is a floppy disk icon right underneath if you want to save the output of the stack. Oh, let's have a look. Okay, now I started the live stack. It's going to take a first exposure, and I'm going to wait a few minutes and see what we get after a few minutes. Now, there's a lot of overhead when I'm using a full frame DSLR like that with so many megapixels, because there's a lot of processing going on. So even waiting a few minutes, maybe only half of that is used for light accumulation. And for proper light accumulation, it's really much better to have like a lower megapixel count sensor and APS-C as well. So this is really like kind of a worst case type of scenario. Okay, and I've waited just a couple of minutes, and the result is so cool. I'm gonna stop the exposures for now because like we see already so much. Now this is where I regret not having an APS-C sensor, so I could so it would be cropped to have a smaller, tighter FOV, a field of view on the target, but also I'm regretting not having a 300mm lens for my full frame camera here to get more details. But this is so cool because we can see the Great Orion Nebula, and we'd be able to see it better with a tighter sensor or a bigger lens. And we see like the core of the nebula, but also on the top right in that vicinity there's another nebula called the Running Man Nebula that's also becoming visible with our light accumulation, and we see the characteristic shape of the core of the Orion Nebula. And man, I wish I had that a 300mm lens, but this shows you the potential of using your DSLR, your mirrorless camera, together with your lenses as a freaking smart telescope that just like moves up on its own, goes on its own to the targets, and then like accumulate light on them. I love this. This is really super cool, and I hope that this tutorial today has helped you like envision what is possible with just a camera and the setup that I described in this video. I've turned the light back on for now. I'm probably going to look at a couple of other targets with this camera because this is just so cool. But yeah, I hope you enjoyed this video. Thank you so much for watching. If you're interested in astronomy, astrophotography, and you're planning on transforming your DSLR or mirrorless camera into a full-fledged smart telescope like you see here that's smartphone controlled, feel free to leave a comment down below, and also leave a like on that video. And if you're new to the channel, welcome to the channel. I do tons of videos about astronomy and astrophotography, and so if you want to see further videos on that topic, please consider subscribing to the channel and clicking that bell icon to be notified of when I publish a new video. Yes, if you do plan on converting your DSLR mirrorless camera, good luck with that. I think it's going to be a super fun project, and I really hope that you get awesome results out of it. Also, remember, I say convert your DSLR mirrorless, but you can really remove it from this setup anytime you want. It's very easy to just use the camera during the day as usual and then plop it on your smart telescope in the evening to do an evening session with it. And I think, like, also for parents with kids as a project, it could be super cool. And again, I really hope you have enjoyed the video and you will enjoy the project. And with that, again, thank you so much for watching. As always, whenever you can, don't forget to look up at the stars, and I'll see you next time.